תבדוק, זה גוגל.
מה אני עורך שלי?
תבדוק, זה גוגל, זה פשוט לדעת. זאת לא היו עושים עליהם קורס.
Okay, so hi everybody. I see that there are less people today. I really actually are the English speakers. Yes. Okay, it's not. I'm not saying it for you, obviously, but if you can pass the message that I really encourage you to not rely on the recordings of the lecture. It's a very different experience, and there is a strong correlation between class attendance and grades. So if you want to improve your chances to get high grades, this is one thing you can do, just come to the lecture. Okay, so we've seen, basically we've covered until today all the very basics of Python. How is it going generally? How are you feeling? Is it easy, hard? Is it similar to things you already knew? Do you feel it's you're learning something, or everything we did is stuff you knew?
לומדים, אבל זה די טכני אותי דווקא.
זה די טכני, כן. זה programming, it's a course in programming, indeed. Okay, but for those who had experience in programming but zero experience in Python, do you feel it's very different from what you did before?
Yeah. So it's different. It's got, once you do the stuff that's different, I mean, you just do whatever you wrote in C, you could put it in Python, it'll work. But once you start doing the Python stuff, it feels completely different. It's like it's a different kind of problem.
Okay. And did you have a chance to try queries to Stack Overflow, for example? Like asking Google things?
Of course, yeah.
Okay, good. So one of very common question in Stack Overflow is, what is the Pythonic way of doing blah? Okay, for the reason you just said. There are many things that you could write with a very strong C accent or IDL accent or MATLAB accent, but if you want to write it the elegant Pythonic way, what's the right way to write it? Okay, so now that we've covered the basics, today should be very exciting because we're going to multiply all the superpowers that you got until now with something called modules, which I think is maybe the #1 strength of Python. The fact that you can, on top of the basics, you can import all kind of capabilities from libraries that other people have written. So there is the standard library, which are things that you don't have to install actively. They're already there at the very moment you install Python. There is a whole range of capabilities that you can import and do. And then there are other libraries, very common libraries, like if you heard about NumPy, SciPy, Pandas. So we're going to cover all these libraries, but these are libraries that have been written by very good developers. They've been tested, they've been optimized. Very often they've been written in C. So if you hear someone telling you, oh, Python is slower than C or things like this, so many Python libraries have been written and optimized in C, so we can benefit from the speed and the advantages of other languages. And as I said, these libraries have been optimized, so you can rely on them, and they add all kind of capabilities to what we've already seen. So today, in the first part of the lecture, I will show you how to import a module in the most general case. I will show you how to write your own module and what exactly we mean by module and how to use this module that you wrote. And after this, I will show you some of the standard libraries some of the standard library modules. So some examples of modules that are within the standard library that you get for free. You get everything for free in Python, but some of the things that you get when you install Python with no need to install anything on top of this. And then we will talk about a very common library called NumPy, which basically adds an array language to Python, because you might have noticed that we spoke about many basic data types until now, but we didn't mention arrays or matrices yet. And as you know, they're the bread and butter of programmers. So we'll see today how to add an array language in Python. I think there isn't a built-in matrix and array language, but really no one uses what's already, like, people use NumPy for arrays, basically. That's the basics, basic Python package and modules for manipulating arrays. Okay, so let's do this. So I've written a small module already, so that we don't waste time. So this is, I called it my first module. Okay, and so you see it's called my first module.py. And one important thing is that this file, so first this file ends with the .py ending, okay? This is an important point. And so if you see here, these are all the files that are related to this course. The nice background we have on Moodle is here too, but basically all the functions that we've written so far are here. And the important thing is that I put this file, this .py file, in the same directory as the code that we will be writing today. Okay, and this is, you may not understand it right now, but this is very important if you want to write a module and use it in your code. Okay, it's very, the directory where you put it is critical. Okay, you want Python to be able to find it and use it. Okay, now let's see what I put in this file. Okay, and then it will become clearer what we mean exactly by a module. Okay, so I put here a command to print something. Okay, so it's printing. I imported my first module. Okay, and then it's already defining a certain variable. Okay, I called it test. Okay, and then I've also defined a function here. So we spoke about functions last time, and let's see what this function is doing. Okay, it's basically receiving as an input a sequence. Okay, so you remind me what we mean by sequence. Give me examples of sequences. List, strings. Okay, these are the sequences with dictionaries, right? We saw several examples of sequences so far. Okay, and so it receives a sequence to search and a certain target value. Okay, and what this function is doing is that it's looking for this sequence for this target value, and it's returning the index of this value. Okay, so we'll see in a minute an example. Questions?
What is the minus one for?
So if it's found the value in the sequence, it's returning the index of this value. And if it didn't find anything, I don't want it to return none, so I asked it to return -1. Okay? More questions? Everything is clear? Okay. So this, I remind you, is a distinct file called myfirstmodule.py. Okay, and I now want to import the things that are written in this file. Okay, and by import I mean that I want to be able to use whatever code I wrote in this file in another piece of code. Okay, this is what we mean by import. So let's start a new code. So by the way, I hope everybody saw that I've uploaded the lecture notes after each lecture. Okay, so everything we write here is on the Moodle. Okay, so let's start. And I'm going to use for the first time this import command, which is really going to give you superpowers from now on. And I'm importing my first module. Okay, so let's see what happens when I run this code. So you see that it's printed. Remember that in my first module, I told it to print this. Okay, so one thing we see is that if we import my first module, it's going to execute whatever is written in my first module. Okay, so let's see. No, this will do after. Okay, so it's executed whatever we wrote in my first module. Now, let's see what happens if I was trying to import something which is not in the directory. Okay? So I'm asking it now to import a file called my second module. Okay, so it's complaining, it's telling me no module named my second module. Okay, so this is where you see that what I said before, the directory where your module sits is crucial for your ability to import it in your code. Okay, is it everything clear? I see a puzzled face. Okay? Okay. So it's crucial that the module sits in a directory that Pythons know how to search. Now let's see if we can use the function that we wrote in my first module. Okay, I want to use this function find index. So I'm going to define a sequence, and this sequence is going to be a list. So physics, literature, geography. Okay. So what do I need to do in order to use the function defined in my first module? Okay. So the syntax is the following. If I only do let's try to only use this this function. So the sequence to search is courses, and the target value, which one do you want us to search?
Yeah.
Huh?
Yeah.
Geography. Geography. And maybe you're familiar already with the ways that PyCharm notifies you that something is not going to work, but basically it's not recognizing this function. So in order for Python to recognize it, I need to use this following syntax. Module. Okay, and now it's not complaining anymore. Okay, so you see that this is the way to use a function that was defined within this separate module. Okay, and it's printing the index, let's see, 0, 1, 2, 3. It's acting as expected. Okay? Now, what if I want to use a variable that was defined in the module? It's going to be the same. Okay, let's see. I want to use this test variable. So it's going to be the exact same syntax. My first module dot test print variable. Okay, and you see that the same way I was able to use a function that was defined in the module, I can also use variables which were defined in this module. Okay, and this is very useful, for example, if you have a large code and you want to be able to define a parameter file for this code. Okay, let's say you want to be able to change, your code depends over 10 parameters and you want to be able to change the values of these parameters. So you would define all the parameters in a separate file as variables, and you would do import parameters.py, and you'll be able to use all the variables in this file. Okay, this is one example of a very common use. Okay? Okay, so we don't have to use the entire name of the module. Okay, we can use something shorter. So let's decide that I don't want to have to write my first module every time. So you can do the following. Okay, you can import my first module as mods, but I could put here anything. I could put cake, I could put one letter, okay? And here I'd have to use the name I chose in the syntax, okay? Okay? Good. And you'll see that we do this a lot. For example, with NumPy, no one imports NumPy. People import NumPy as NP, okay? And when you ask Google about issues in NumPy, very often you can write the exact same question with NP because people know what you mean. Same with pandas. Pandas is PD, okay? But really, you can choose. It's completely modular. These are conventions, but you can import NumPy as pandas if you want, okay? If you really want to confuse yourself and make bugs that didn't have to be there. Okay, so
You can also import something specific from itself.
exactly. So this is the next thing that I wanted to mention. So let's assume that I only want to import the function. Okay, so here it's not very clear why I would do this, but imagine that you've got 100 functions in this module, okay, and you only want to use one function. So the way you would do this would be from my first module, import find index. And let's also import the variable, okay? In this case, you wouldn't have to specify mod.blah because Python already knows that you imported these two things from my first module. So let's see. Okay, it's still working. Okay? And you can also combine the two things we just spoke about. If you want, for example, to only import find index with a different name, decide that we want to import it as fi, okay? Then, so if you do this, it would know you mean find index, okay? And here, it complains because you didn't import test from my first module, so it doesn't know that you want to use it. Okay? Make sense? Yes.
אז
תזכיר לי, עומר.
אז למה שנשתמש בפרומים פורט ולא נשתמש בהכל? נגדירו מראש הכל.
למה שבכלל נשתמש בספציפיים?
כן.
Sometimes it's just a convenience. Like sometimes you want to use one function 100 times in your code, and it's a function that comes from NumPy, and you don't want to write NumPy dot this function every time. Okay, I don't think it's such a big deal to write it every time, but okay, let's assuming that you don't want to write where it came from every time, you can just import this one function, okay? Now, it's very good practice actually to not do this, to basically keep writing NP or NumPy. If you really want to make things shorter, you can import NumPy as NP, okay? But it's good practice to always write NP dot your function so that you know where it came from. Okay, and there is, I will show you this, but it's something to be aware of, but I think it's a bad idea to use it. Again, it's all about avoiding useless bugs, okay? There are so many bugs already that are hard to find, so if you can avoid as many as possible, it's better, of course. So you could do the following. For my first module, import everything. Okay, and if you do this, it will know what you mean by find index, it will know what you mean by test, and this is on the one hand very tempting, but on the other hand, it makes it much harder to track where different functions came from. So if you import at the beginning of your code 20 modules, and if you do this every time, after a while you'll have no idea where your functions came from.
Why is it important?
What?
למה זה חשוב? מאיפה הבאתי?
Okay, so דביר? לא.
איתי.
איתי?
איתי.
Okay. Okay, so why is it important where it came from? So, for several reasons. First, you may have a situation where two functions have the same name in two different modules. Okay? And in this case, it can be confusing. Or maybe two functions would have very similar names in two different modules. Okay? And if you do this, you will not know easily where to look if you have a bug. And the second point, of course, is what I just said, where to look. Assuming you have a bug, okay, and Python is telling you the bug is in function X, okay, and now you want to fix this bug, okay, and function X is within one of the 50 modules you wrote in the last 6 months. So it's much better if you know which module the function came from, so that you can track whatever bug appeared in this code which are related to this specific function. Okay? So, and maybe the more general point here is that modules allow you to basically spread your code over many different files. Okay? And if you spread, on the one hand, it's very beneficial. Okay, you can make things reusable. You can write certain modules that you're going to use in 10 different projects. But the price to pay for spreading things over is to write your code in a way that you'd keep track of where things are. Okay? Questions? דביר?
כן. אם אני מגדיר שני מודולים שונים, ואני מגדיר ביניהם עוד פונקציה שיש לה אותו השם. ואז אני עושה from, כאילו, משני המודולים האלה אני עושה להם אימפורט לפה.
כן.
ואז אני עושה, כאילו, מנסה להביא את השם של הפונקציה הזאת. אז איך פייתון...
איך הוא יודע לאיזה?
כן, איזה פונקציה זה...
אז, okay, so Dvir asked, what if you define the function with the same name in two different modules, and you wrote from, let's say, from my first module import find index, and from my second module import find index. Okay? So I think he would use the last one you defined. I'm not sure. It's something you can try. But a good way to prevent errors which could arise from this situation is, instead of using this syntax, is to write import my first module, say as mod, okay, and then import my second module as mod 2, okay, and then you can call the function with mod.findIndex and mod2.findIndex, okay, and then it will know which findIndex you mean, okay? It's clear? Okay.
אפשר להגיע למצבים כאלה?
אפשר להגיע, כן. זה הכל תלוי באיך אתה כותב את הקוד שלך.
אפשר שוב את ההבדל בין אימפורט של כל הקובץ לבין פרום הקובץ אימפורט כוכבית?
Import, okay, what's your name?
נחלה.
Hana?
נחלה.
Nachala. Nachala asked what's the difference between writing import my first module as mod or from my first module import a function?
לא בדיוק. כאילו import my first from my first model import כוכבית שעשית.
אוקיי.
import כוכבית לבין פשוט import של הקובץ.
import של הכל? like import כוכבית?
מה ההבדל בין import כוכבית לבין import של הקובץ?
מה זה של הקובץ? אוקיי. So Nachala is asking what's the difference between this and this?
Yeah.
Okay? So, okay, if I write this, then every time I want to use a function in my first module, I need to specify where it comes from. Okay, and if I do it like this, I can make this shorter. Okay, but if you do this, you need to specify where the function came from. If you do this, you don't have to, but it's not necessarily good. Okay, it's a matter of preferences, but this is more likely to bring bugs. Yes?
What does the star mean in general?
Star in general means everything.
Joker.
Okay. Now, one of the reasons you would want to use this shortening is that sometimes, okay, they are like chain import. Let me specify. Sometimes you want to import a function from a function from a function from NumPy, okay? And then you'd have NumPy dot blah dot blah dot blah, okay? So this may be a reason to use these shorter versions of your module namings, okay? Okay. Okay, so what we did until now is we imported a module which was in the same directory as the code we are writing, right? But I already said that today we're going to talk about all kinds of modules. Okay, some of them you don't even know that you have them, but they've been installed in your computer from the moment that you installed Python. And obviously these modules are not in the directory where where I'm writing the code, right? So let's look at an example. I'm gonna remove this for the moment.
אבל לא אמרתי צריך שהמודול שאנחנו מייבאים יהיה בתוך אותה תיקייה?
כן, זה מה
אז
שאמרתי.
איך יכול להיות שיש כאלה שהם מובנים בתוך ה...
Okay, so let's see. Okay, I'm now importing a module called math, and I'm telling it print math py. Okay, so it's imported. It has imported my first module. How do I see this? Because it's printing this, so it's executing what's there. But it's also imported the math module. Okay, and it knows that to call a certain variable within the math module called py, okay? But math obviously is not in the, do you see here math .py? No, it's not in the directory where we're working, right? So what we see here is that you can import modules from other places. Now the question is, how does Python know where to look for modules? Okay? So the place where the module is located, so you can print out this place, okay, and to print it you need another module called sys, okay. So I'm going to ask it now to import the variable path from the module sys, okay. So what does it print? It prints a list. Okay, it prints a long list of paths. Did you already come across the concept of path? No? Okay, so some people said yes, others said no. Right, so a path is basically an address in your computer. Okay, and it takes the form of a string. So this path tells me the address it gives me is a directory called Python. Okay, and this directory is located within the user's directory in my computer. In this directory there is another directory called מעיין Sumaniak. Then I made a faculty directory in this directory, etc., etc. Okay, so now you all know where the Python course is located in my computer. Okay, so this is one path. Okay, one string telling me the address of a location in my computer. Okay, so let's look at this list. You see that here we have a list of paths. We don't only have one path, we have a list of paths. So you see that the first path, actually the first two paths, I see it's repeating it, is the directory where we are located. Okay, this is where we are. So the first place where it's going to be looking for a module, okay, when you write import module, it's going to go through this list of paths and look for something called like the module you're importing. Okay, so the first place it's going to look for is the place where you run your code. And this is why we were able to run my first module earlier. Okay, because it looked for the directory where we're running the code, it found it, so it stopped looking for other places. Make sense? Okay, let's see now what is the next place where Python will be looking for modules that you want to import. So this is called obviously it's going to be different on your computer, okay? And this is called the Python path environment variable. I think this is the one. And then it's going to look for packages in the location of the standard library. Okay, I told you, remember the standard library is this library that comes with Python when you download Python. And where are all the things, all the modules of this standard library? They are located in a path which varies from one computer to another. Okay, I encourage you to check on your own computer where the standard library has been installed. But in my computer, it's installed in this location. Okay. Okay. So these two are places where the standard library packages have been downloaded. Okay. Now, what happens? I showed you what happens if a module is not in the location that we're looking for. So let's move. For example, I'm going to move my first module to the desktop. It's writing in Hebrew. Users, מעיין, סומנייק, teaching Python. Okay, so what I've done now is I've moved. I could have done it by dragging the module, by opening the directory and dragging it, but what I've done now is that I moved my first module to another location, to the desktop, okay? And now if I try to import it, it's going to complain that it doesn't exist, my first module. Why? Because it's neither in the directory nor in any of the paths that is defined in the syspath variable. Okay? Okay. So if you're in this situation, there are several approaches. Okay, you can modify manually your syspath variable. So let's say that I really want Python to go and look for modules in my desktop. Okay? So I can do the following. I can do syspath. You remember, how do I add an element to a list?
Good.
Okay, so let's add to the syspath list. So if you were wondering, these are Linux commands or bash commands. So, okay. And this is giving me the path of my desktop. So I'm adding this, I'm adding here the path of my desktop, okay? So print before adding desktop sys.path is okay. So what did I do here? Okay, I'm adding manually a location, a path to the syspath variable. Okay, so
because of the import.
Let's see if it works now. Yes, it's working. So before adding desktop, the syspass is ending here, okay? And then I've added manually the desktop location pass to the syspass list, and then it's finding it, okay? This is not the best way to do things. It's not the best approach. The best is to change what we call the Python environment variable, okay? And so a better approach is to change. So I'm going to remove this. Okay, to change what we call the Python environment. So there is a variable somewhere in your computer which is called the Python path. Okay, and this has the location where Python will be looking for things. So in Linux, the way and Mac, the way to print this is this command. It's not very important for our purpose, but one thing that I'm giving you as a homework for next time, okay, is to check in your computer what's the Python path variable and how to modify it. Okay, so it varies if you're using a Mac or Windows or Linux. There will be a different answer, but I want you guys to be aware of this thing and be able to modify it if you want. Okay?
How do you modify it?
So it depends. So so in my case, because I'm using Bash, which is the language for the Mac or Linux terminal, what I would do is I would write export Python. Let's assume that I want to add to my Python path the desktop location, so that Python knows to go to the desktop to look for modules. Okay, so I would do the following. I would do export Python path equal, and then the location of my desktop, which I don't remember. It's here. Okay. Now if I do this, I might have to restart the. Okay, if I do this, let's see if it looks my first module. Okay, so in my case, because I'm using Bash, okay, Bash is the language that your computer speaks if it's a Mac or a Linux, okay, machine. So in my case, the way to modify the Python path variable is with this syntax, by writing in what we call the terminal export Python path and adding the location where I want Python to look for modules, okay? And if I do this and I start a new Python instance, it will know to look there for modules, okay? Now, in your case, because I don't know what you guys are using, I don't want to tell you this is the right syntax. So this is something that you guys need to check for next time, okay? If you want Python to look for a specific location for modules, how would you modify the Python path variable in your computer? Okay? This is a task, an assignment for next time.
Can you try to import math now? I want to see.
Sorry?
Can you try to import math? No, because it seems like not from here, from
Here?
the terminal.
Yes.
It seems like you cover the two.
No, it's basically it's adding. It's appending this location to the Python path. So, is it?
I think if you want to append it, you use
Interesting.
Python pass equal to a dollar Python pass, you know, and the order.
How did it import mass then?
I don't know.
Interesting.
Maybe there is some built-in Python pass.
Interesting. Import sys print sys. No, because I think okay. Right. So it would still, so Python would still go and look for all these locations, whatever is in the sys.path list. But one of these guys is the Python path. So, you see what I mean? And this is the reason that it knows how to import math, because it would still go through this entire list. But one of them now should be the Python path with the desktop. Right. The second one here is what's in the Python path variable. Okay?
So
But if I restart, I'm just curious to see what's the Python path by default. Right, so, okay, so this is because specifically in my computer, okay, it's not a virgin computer that has only been designed for this course, okay? I'm telling my computer to export things in the Python path whenever I open a terminal, because I need this additional code. But I think that on your computer, the Python path would be empty by default. And then if you add a location to the Python path, it would be added to this list that you see when writing the sys.path variable. Okay?
So what is the difference between changing the sys.path, the second argument, or the Python path itself?
Right. So there is a file in your computer that run the. So when you will check how to change the Python path, okay, the answer will be that you need to go to a certain file and add a command such as export, similar to what I just wrote, okay? And what happens is that every time you open a process, a terminal, or you run Python, it would run this file automatically. So you won't have to redefine the Python path every time. Whereas here, if you want to append something to the sys.path, it's not a bash, or it's not a command that is written in a computer language that runs automatically every time you open something on your computer. It's something that runs from Python and that you would have to run from within your Python code every time. So it doesn't make much sense. It's better to do this in a more automated way that it's not automated, but in a more systematic way that just populate your Python path with wherever location that you want Python to look for modules every time you open Python. Okay? Okay. So
let's go on the export.
Okay. I said that okay, so let's summarize. We saw that we can write modules, okay, that increase the capabilities of Python in some way, and for Python to recognize them, they need to be located in specific locations, either in the same directory that you're running your code, or in any of the locations listed in the sys.path list, okay? And then we moved a module and asked, what if I want to add a new location that Python would be looking into when I run a module. And we saw that there are two ways to do it. Either you can do it in Python, okay, and append a location to your sys.path variable, or you can do it outside of Python by writing a command, which in my case is export Python path blah blah blah, but in your case, depending on what system you use, it may be slightly different. And this is another way to modify the locations where Python would be looking for modules when you call modules, okay? And איך אתה יודע? אתה חוקר את השאלה הזו עד הפעם הבאה. אני בכוונה רוצה שתחפשו את זה כל אחד לפי המחשב שיש לו. בסדר? אוקיי. זה בש, זה מקס, זה משתמש באותה שפה כמו שלי. אוקיי. So now what we covered is how to write your own module and import your own module. Okay? Now I would like to move on and talk about modules which we didn't write. Okay? Two kind of modules. The ones that are in the standard library and the ones which are in additional library. So remind me, what's the difference? What's the standard library?
And what's coming with the Python itself?
Right. You don't have to install it actively. Okay, it comes with Python. So let's explore a bit of this standard library, which again are you can trust them. They are optimized. They are very useful. They've been tested together with the Python version before the Python version has been released, etc., etc. So let's see a few examples, and I hope you will get a sense of how powerful these modules can be. Okay, so let's look at the random module. I need to redefine my list of courses. Math, physics, geography, history, Hebrew, literature. Okay, and let's see. I want to pick an element from this list randomly. Okay, so you and I, with a lot of thought, could probably write in Python a function that does this. Maybe. Okay, but you might as well import random. So let's see what random is doing. So courses is, so what is choice? There is a function in random called choice. Okay, there is a line in the random module that says def random. Okay, and then does things. I don't know what it's doing. Okay, random course, and then I'm going to do it again and again. Okay, and hey, it's picking courses randomly in this list. Two lines of code. Okay. לא יודעת מה זה רנד ב-C++, אני חושבת שרנד ב-C++ זה גנרטור של random numbers. I think it's exactly the same, but it's picking randomly something from this list.
באמת רנדומלי שזה פסאודו.
לא, אבל איך זה יכול להיות רנדומלי אם זה לפקודות? כי בסוף בתוך הקוד מה שהם עשו שם, הרי יש שם if ועוד לא משהו בסדר.
Right, so Itai is asking how can it be a random process, and the answer is I don't know, but there are many random processes happening within your computer that you can hijack on and to do things randomly. But the real answer to this is that you should not be shy of going and looking for what is written in specific modules in the standard library, and we're going to do it in a second. Okay, so the standard library, on our everyday work, we do consider it as a black box. Okay, I want to be able to import math and use pi as math.py without going and looking into how it was defined. Okay, but you should know how to open codes in the standard library, and I think you can also modify codes there. I also think you should really not do this, but you can if you want. Okay, it's something that it's open. Okay, this is one of the great things about Python. It's completely open. It's editable. You can do whatever you want. So let's take another example, and then we will go and look for a specific function in the standard library. So I already showed you import math. Okay, so I showed you math.py, but there is an endless amount of things you can do with maths. So radians would convert degrees to radians, and then let's assume I want to take the cosine or the sine of this. So there is a function called math, and this, by the way, is one of the amazing things about PyCharm, is that it's showing me all of the options. Okay, all these things here are all the functions that are defined within the math module. Isn't it great? If you're using another editor, it won't tell you what functions are available, right? So let's try the cosine. I could take the arcsine as well, but let's keep it simple. So sine rads. Okay. So it's taken 90 degrees, turned them into radians, and then it took the sine of this value, and it's giving me 1. So this is a good opportunity to show you that math.sine acts on radians by default. You need to give it radians in order for it to do the calculation correctly. Okay. If I give it here, it would probably complain, right? It complains. So math.sine takes radians. So this was one example, but as I showed you, there is a very large amounts of function within the math module. Let's look at another module from the standard library.
דרך פשוטה לבקש שזה יראה את הרדיאנים ככפולות של פאי, במקום פשוט כמספר.
זה הדרך הפשוטה. סבבה? Okay, so let's look at another nice module from the standard library. There is one called daytime and one called calendar. Do you guys need a break, or do we continue until 1:30? Okay, who wants a break? Who wants to continue until 1:30? Okay. But as I said, the price to pay is to keep the. I want to see energetic people. So, okay. So I imported these two modules, and I'm going to show you what they can do. So datetime dot date dot today. Print today. So you remember I told you that you can have chain import things. So you see here it's datetime.date.today. It could have been datetime.date. Blah 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 for a very long time. So this could be one reason to import datetime as dt, for example, and then here it would be shorter. dt. Okay. So let's see what it tells. Okay, it tells me the date of today. Amazing. Okay. We will see in a minute. You asked. Okay, so Itai said, how can it know? So, and the answer is that there is another function in your computer, a module that has already been written by other people, okay, which knows how to go and pick in your computer what's the date today, and you don't have to do it. Okay, it's saving you tremendous amount of work. So, and this again, these are only the standard library that comes whether you want it or not. Okay, imagine how many things you can do that you don't even think you want to do. So let's assume that I want to know what is a leap year. Do you know the leap year things? What's שנה מעוברת? Is that Hebrew? Okay, so there is a function called isLeap in calendar. Calendar.isLeap that tells me if 2017 is a leap year or not. And there is, let's try. Okay, so 2017 was not a leap year. 2020 was a leap year. Okay, now we're going to go and look at this calendar function. And you'll see that you could have written a function that does this, okay? You would have had to go on Wikipedia and
figure out
understand how are leap years calculated, and then make the calculation for yourself, etc. But someone has already done this for you.
מתחלק ב4, לא מתחלק ב100, כן מתחלק ב1000.
כן, זה לא בדיוק 4, כאילו, אוקיי? Okay, now another one, import OS. This is also, the OS one is a very important one. So this is giving you access to, the OS is for operating system, and we'll see examples of this in the future. I'll show you one example, okay? So let's assume that you want to get the address, okay, the path of the current library the current directory sorry, I'm getting tired. So let's assume that you want the path of your current location, okay? So you do the following: print os dot, I think it's get. Yeah, yes, so it's get CWD. So CWD is for current working directory, okay? And this, I need to do this. Okay, so it's telling me in which directory I'm located. Okay, so OS is a module that is going to give me all kind of informations on the underlying directories, files, okay, where I am exactly in the computer, basically interacting with the operating system and the computer language as we saw before. So I think you can modify the Python path with the OS package too. Okay, now you can change file names, you can change directory names, you can change all kinds of things that have to do with the operating system.
Yes.
Okay. there is, yes? כן?
מתי שיש את ה-today, שזה dt.day, מה אם היית מכניסה ערך לנקודה today, כאילו בסוגריים? מה היה קורה? מספרים.
פה?
כן.
לא יודעת. אפשר לנסות, אתה יכול לנסות. לא נראה לי שהוא היה אוהב את זה, הנה. It takes no argument. הוא אומר לי, today is not a function that takes arguments. You cannot give it an argument. Okay, now let's. I said that we would go and actually open things in the library, and so. Okay, so the reason I printed this was that I wanted to check where is the standard library in my computer. Okay, and it's given me this path, so you need to follow me now for a second. Okay, so this is the place in my computer. It's going to be different in yours, where the standard library is stored. Okay, and you see that there is a long list of modules here. So one of them is calendar. Okay, let's look at let's go to this location and let's look at the calendar module. And let's see how did it know that the function was a leap year. Okay, so this here is the function called isLeap, which I called, and you see that it's doing a division by 4. Okay, this is what you would have coded if you were to write a function that knows if a year is a leap year or not. Okay? Yes? Okay. So I've looked now into the calendar.py. Now there is, I don't know if I told you, but there is a whole culture of geeky jokes in Python, I think in many languages, but in Python it's usually related to the Monty Python. But in any case, you see that there is a module here. So here, this again is the list of things that are in the standard library. So let's see if math is here. You see that we have random here. This is a module that I called in the beginning. And math, where is math? Where is math? Good question. I don't see it here.
You need to scroll down.
It's not here. Interesting. It might be in the site packages. Anyway, what I wanted to show you is that there is a module here called anti-gravity. It's here. So let's see what it's doing. Okay, so this is what's written in this module. So it's importing this web browser module that we haven't talked about yet. Okay, let's try to understand what it's doing. Okay, if I do import anti-gravity, what is going to happen? So it's doing this web browser thing, okay, and then it's going to this location, to this address on the internet, and it's doing something with this address, okay? So this address, I'm going to open a new browser. Do you know XKCD?
את התמונה במודל.
נכון, it's the picture I put in the Moodle. It's so XKCD is a funny comics, a bit nerdy. So do you know this? It's a very funny one, I think. Okay, so it's going to do, if you do import anti-gravity, something is going to happen with this picture. So let's try it. Okay? Let's do, I'm getting rid of all of these. Import anti-gravity. It's opening my browser. I've closed it, okay? I've closed my browser. Quit. It's opening my browser and it's opening on this page, okay? This is what it's doing. So this is more like a joke. But the important thing I wanted to show you here is that you can import all kinds of packages from the standard library. We saw where this library is located. We saw that it is on our everyday use. It's used as a black box, but it doesn't have to. If you're really worried about how on earth could Python know what a leap year is, you can just go and look for the module in the standard library and open it. I opened it with the Vim editor because I like Vim, but many people don't. So you can open it with your favorite editor and see what it's doing. Okay, and this is what we've done with this anti-gravity module. Okay, what on earth could an anti-gravity module be doing? Okay, we saw that it's probably opening this page, and this is indeed what it's doing. Okay. Good. So the last thing that we will cover now in the last 15 minutes, okay, is a third type of modules. Okay, so the first type that we saw were the modules which we as users, as programmers, are writing. The second type of modules were the ones that are built in the standard library. And then the third type of modules are kind of in between these two categories. They are in between because they don't come automatically with the Python installation. But on the other hand, they've been written by real people, not the Python programmers. And you can install them and use them, okay? And the library which we will talk about now is called NumPy, and it's a library which is extremely useful because it basically adds an array language to Python, which we were missing until now. Okay, so I'm going to import it as NP, okay? I don't want to have to write every time numpy.blah. I'm importing it as NP, okay? But I should say, I can do this because I've installed it before. So if you install Python with Anaconda, it may very well be that it also installed NumPy by default, but it depends on how you did the installation. You might have to install NumPy actively. Okay. Okay. So one important thing. Okay, arrays are not lists. Okay, and because arrays are not lists, we should be very careful in the language we use to make a clear distinction between these two. So I told you that that some of these modules are written in C, okay? And let's see an example of this. So let's see an illustration of why use NumPy, why we could in certain cases stick to list and use lists, okay? So there is a function called arrange in NumPy, which is very useful. Okay, so arrange is printing this array. It looks like a list, but it's really not a list. Okay? If I ask the type of A, it's gonna tell me that it's an ND array. Okay? It's not a list. Okay? It looks like a list, it's not a list. Now let's see one of the differences between an array and a list. Okay, let's assume that I have this okay, and B is okay, and C is equal to A plus B. So this is a good opportunity to tell you that operations on arrays in NumPy are working element-wise. Okay, so A plus B is going to basically make an addition of the first element of each array, the second, third, etc. Okay? And there is a package called time, okay, which allows me to time things. So let's time the operation A plus B. So T initial is time.time, T final is time.time, okay, and it's going to print the command to X seconds to run. Okay, it took 0.03 seconds to do this operation of A plus B. Okay, now let's assume that I want to write the same thing with lists instead. So you remember how we generate range, okay? So I could use the range, I could use list and the range thing, the range comment instead. Okay, let's do D, B, C, D, E equal range. Okay, and then I will make F a list instead of an array. Okay, and here I would have to write a loop. So for I in range len A, C append A I plus, no, it's not A, it's D I plus E I. Okay.
Len also.
It's len D. Okay, and let's time it to
F append, you meant, right?
Yes. Okay, so this took a bit less than 100 times more. Okay, so for these times it doesn't look like a big deal, but these things accumulate in your code, and you want to use the NumPy library, which has been written and optimized in C, in order to do everything that looks like a vector and matrices operations. Okay. So of course, I've shown you now only 1D arrays, but you can also define 2D arrays. So what I'm going to do now is to show you a few examples of what is NumPy in the 7 minutes left. I'll show you a few capabilities of NumPy that are interesting. So there is a function called shape that gives you the shape of A. So A is a one-dimensional array in this case with 10 number. Print A. But I can also define the 2D array. And the array 1, 2, 3, 4, 5, 6. Okay, print B, print the shape of B. Okay, what did I do wrong? Maybe this is the syntax. No.
I think you need to use np.array instead of np array.
Ah, np array like this. Right. Okay, so thanks. What's your name?
Johan.
Yes. So yeah, I did a small mistake here. So here, so we defined A. It was a one-dimensional array. It was 10. It was 1 by 10, 1 line by 10 column array. And here we defined this B array, which is basically a matrix. Okay, a 2 by 3 matrix. Okay. So this is the shape, and all the matrix and vectors operation that you can think of, you can do them very easily with Python, with NumPy. Okay. So there is an important package called linalg that allows you to do linear algebra on NumPy arrays. Okay. But I have 5 more minutes, so I'll show you a few more interesting things. So np.i10. Let's make it smaller. Okay, so this is the identity matrix. It's a 5 by 5 identity matrix. Okay, there is also a useful one called ones. So this is what happened here. So this is a 5 by 5 matrix full with ones. I'm missing parentheses here. Okay, this is a 5 by 5 matrix filled with ones, and you'll find it useful sometimes to just populate a matrix with zeros if you assume that you want to initialize a matrix with zeros. Okay, so this is a 5 by 5 zeros matrix. And I'll show you two more very useful examples. So one really nice thing that you can do with NumPy is have conditions within your array. So let's give an example. If I have A equal, I might have it here already. So, okay, let's random. There is the numpy.random. Okay, this is an example where the random function appears in several different modules. So NumPy has a random function. So it basically fills an array with random numbers.
Why do you have random dot random?
So in order to understand this, you'd have to go to numpy.random and understand this. But basically, I could have done from numpy import random and then random.random. And then let's assume that, so this is going to be a 1D 100 long array. So let's check it to be sure, okay? And then let's assume that I want to print all the values of A that are greater than 0.6 or smaller than say 0.2. Okay, so I can do this with NumPy. I can have Boolean arrays. Okay, so this indeed was 100 items long array, and it's only printed the elements that match these two conditions. And this is taking me a fraction of a second, and if I was to do it with the least language, it would have taken me much longer. Okay? Okay, and the last, I have 1 more minute, so the last very interesting thing you can do with NumPy, although I will strongly encourage you to do it with pandas instead, is if you want to read a file, okay, if you want to read an array from a file, you would use a function called gen from text, name of the file. Okay, I'm not going to do this. I can do it, but it's going to complain that there is no such file here. But next time I'll show you. I'll make a small file with an array, and I'll show you that it works. And so this is why is this important, because it's one way to load data from a file. Okay, if you have tabulated data in a file on your computer and you want to load it to your code and start manipulating this data, this is one way, to use NumPy and then this gen from text, which is generate from text file function. Okay, so again, it's not going to be the preferred way we're going to use it, but it's one very powerful way to do it. Questions? We're done, but if there are questions, I can stay here for a bit.